Good evening, ladies and gentlemen. Thank you for giving me voice. Today, I will be talking about the recent article published in recent number of Journal of Water Process Engineering and the leader team of Atatürk University and Erzurum of leadership Aysenur Karakash and Akram commercially with Sparta University Applied Sciences of Dr. Seda Tosun Akgul, and finally with cooperation of the Department of Environmental Engineering and Suleiman Demirel University of Professor Sehna Sule Kaplan Behar Bloglu. This study presents the carbon footprint assessment of an advanced biological wastewater treatment plant. Greenhouse gas emission sources of the plant have been identified, and the processes from which these emissions originate have been determined. In the carbon footprint assessment, direct and indirect emissions were considered by utilizing the United Nations Framework on Climate, International Intergovernmental Panel on Climate Methodology, and national greenhouse accounts. The total greenhouse gas emission amount is estimated from 10,000 to 53 in 2019. The footprint's carbon was 5 times higher in 2019 than 2018. This showed that efforts to decrease are not very fruitful, so we need to really go to work. As a result of the increase in the world population, urbanization, production, and consumption improve quality of life, and developing industrialization greenhouse gas emissions into the atmosphere have also increased. The increase in greenhouse gas emissions in the atmosphere is shown as the main cause of global warming and climate change. Wastewater treatment plants play an important role in reducing environmental pollution caused by wastewater. However, is one of the main sources of greenhouse gas emissions, such as carbon dioxide, methane, and nitrous oxide, as it well known extreme weather events, such as short periods of heavy rainfall and prolonged droughts. Therefore, the wastewater treatment sector is one of the major concerns for today's global warming. In order to operate the net zero emissions, wastewater utilities are pioneering in reducing greenhouse gas emissions. The net zero emissions target set by 2053 with the Paris Climate Agreement, to which Turkey became a part in 2021, also requires taking measures to reduce carbon emissions. In addition, climate change also poses a threat to wastewater treatment plants. Climate factors such as increasing global temperature, extreme temperature, flooding, heavy rainfall, and sea can affect. In order to operate net zero emission, wastewater utilities are pioneering in reducing greenhouse gas emissions. Therefore, wastewater treatment plants above climate change driver and climate change influencers with the energy they consume and the greenhouse gases they emit. The United Nations estimates that the water treatment industries global carbon emissions, which includes wastewater treatment, make up around 2% of all carbon emissions. Several studies showed that wastewater treatment technologies and treatment parameters significantly influence greenhouse gas emissions in wastewater treatment plants. However, the carbon footprint of various treatment technologies and its contribution among different units within each treatment configuration in wastewater treatment plant is still uncertain. Greenhouse gases emissions from wastewater treatment plant are classified as direct and indirect emissions. Direct greenhouse gas emissions are emissions from treatment processes, emissions from the sewage collection system, and emissions from the receiving water environment where treated water is discharged. Indirect greenhouse gas emissions arise from electricity consumption, chemical consumption, fossil fuels for transportation, and sludge disposal. Carbon footprint analysis is an important tool used to assess the impact of wastewater treatment plants on climate change and is useful both in identifying strategies to reduce the greenhouse gas emissions of the plant and in determining the success of these strategies. Carbon dioxide, methane, and nitrogen oxide are the main greenhouse gases considered in the full carbon footprint of wastewater treatment plants calculation of greenhouse gas emissions, as they are considered part of the natural carbon cycle, biogenic origin. Therefore, the sources for carbon dioxide emission in wastewater treatment plants are mainly related to energy consumption in wastewater treatment plants. High energy consuming units such as biological treatment, aeration, pumping stations, and sludge equipment are sources of carbon dioxide emissions from the electricity consumption. Nitrogen oxide and methane emissions are related to nitrogen and carbon cycles in biological transformation processes. The effects of greenhouse gases, such as methane and nitrogen oxide generated in treatment plants, can be compared to the global warming potential by converting them into carbon dioxide equivalents. In the literature, it was reported that nitrogen oxide and methane emissions from wastewater treatment discharge contributed 2.6 and 3.6 to the total emissions of industrialized countries. Consequently, issues such as energy consumption and greenhouse gas emissions, carbon footprint, and minimization of energy footprint have gained importance to ensure the environmental sustainability of wastewater treatment plants. There is evaluated several plants. In Turkey, there are limited studies on assessment of greenhouse gas emissions of wastewater plants. In the existing studies, carbon footprints are made using various program modelings and guidelines. Therefore, it needs to some more emissions by target or by 2053 to which Turkey become part in 2021 and net zero policy reaching. Actual advanced biological treatment plant with a treatment capacity of 13,000 square meters per day, designed to treat the pollution loads given the plant flowchart. The aerobic tanks of the plants are designed to remove nitrogen, phosphorus, and other pollutants that cannot be removed by biological treatment and are therefore defined as advanced biological treatment plant. The wastewater coming from the sewage system first passes through cores and fine screens. The wastewater from the screening unit is conveyed to the grid grease chamber, press settling tank, and aeration basin respectively. Aeration tank is an activated sludge process consisting of anoxic ponds and based on carbon and nitrogen removal. Nitrogen, carbon, phosphorus, and other pollutants in the wastewater are removed by ensuring that nitrification and nitrification events take place in aeration basins. Aeration effluence is conveyed to the final settling tank. The legal and technical principles required for the protection of groundwater and surface water sources and prevention of water pollution in Turkey are specified in the Water Pollution Control Regulation. According to this regulation, the water from the final settling point of wastewater treatment plant is discharged to Karasun River according to river to criteria. The solid matter content of the sludge is increased in thickening tanks. In addition, biogas is produced by digesting the sludge in anaerobic digester in the balance and heat and electricity, also generated from biogas by the combined heat and power system. The study is based on primary data from an advanced biological wastewater treatment plant in Turkey. Data such as wastewater quality parameters such as biological oxygen demand, flow rate, electricity and chemical consumption, biogas production, which are considered carbon footprint calculation, were obtained from plant operational records. In the assessment of carbon footprint of the plant, direct and indirect emissions caused by wastewater treatment are considered. The calculation comprises emissions from wastewater treatment, including anaerobic stabilization, biological treatment, advanced treatment, and emissions from the amount of electricity and chemicals used during the operation of the plant. Direct emissions from the sewer network and emissions from sludge were not included in the carbon footprint calculations. The chemical oxygen demand was 631 milliliters per grams per liter, with effluent standard of 90, and biological is 321, while pH was 6295. Direct emissions at the wastewater treatment plant are from anaerobic destabilization pond. The calculated methane and nitrous emissions are converted to carbon dioxide equivalents based on their global warming potential. So, the national guidelines of greenhouse gas inventories is one of the most emission factor methods to estimate greenhouse gas emissions. However, it can provide preliminary information about carbon footprint for determining process configurations and optimizing operational parameters for a water treatment plant, enabling the plant to reduce its carbon footprint. The methodology, published and developed by United Nations Framework Convention on Climate Change, was used to calculate emissions from anaerobic stabilization ponds. Methane from wastewater treatment accounts for 5% of global methane sources and contributes 3.6 of total carbon dioxide emissions. Methane emission sources in the plant investigated in the study are anaerobic stabilization, biological treatment, and advanced treatment. The greenhouse gas from emission anaerobic stabilization point was calculated as methane emission only, and the methodology developed using framework of United Nations. Methane emissions from anaerobic stabilization ponds is proportional to global warming of methane multiply methane conversion factor of 0.8 and maximum methane producing capacity, which is 0.6 kg per gram of biological oxygen demand, quantity of biological oxygen demand be treated. The methane population emission in the inventory is is degree of utilization, and incomplete the nitrification is taken into account also. This house emissions from electricity consumption, avoided emissions gas produced as byproduct in anaerobic digester in treatment plant can be collected and used as energy source, reducing the carbon energy footprint of the plant. Some stated that the energy total footprint can be reduced 10% by utilizing the recovering biogas energy. In this study, the biogas obtained from anaerobic digestion of the sludge generated in the plant is collected and burned for electricity generation. The electrical energy generated is automatically operated by the transformer system of the plant and is used when the plant needs it. Therefore, the electrical energy supplied from the grid and emissions from electricity use are reduced. The amount of emission prevented as a result of the energy source produced was calculated by converting according to the conversion coefficients table of energy resources to lower thermal and oil equivalent values published by Ministry Energy and Natural Resources for Turkey. Total methane emission from the plant in 2018 and 2019 were 8,548 tons, and 2019 was almost 45,000 carbon. So we see how much increased. The total direct emission were calculated similarly, like Worcester, since the biological treatment is located in different locations than others, both in terms of altitude and climate. The study shows that the standards cannot be met in the concentration of wastewater treatment plant effluent in high altitude and long winter conditions. It took a long time to solve the operating problems that occurred in winter in 2019. For this reason, since 2019 couldn't be obtained from the plant managers. Therefore, the increase of emission amounts of 2019 can be explained by an increase in biological oxygen demand and nitrogen concentration in wastewater effluent. This increase is expected considering that both wastewater is the main determinant of the formation and nitrogen component is the main determinant of nitrogen oxide formation. For both years, emissions from anaerobic stabilization plants have the lowest methane emission belonging to advanced treatment. For example, in anaerobic stabilization plants cause 6,000 tons carbon dioxide of emissions, while advanced cost 372 emissions. Equipment allows mixing motors and other in wastewater treatment is known to contribute to a large portion of the indirect emissions of the plant. In the calculation of emissions from electricity capacity, the annual electricity consumption of plant and country emissions, 0.4 tons of carbon dioxide per kilowatts for Turkey were taken into account. Electricity consumption of wastewater treatment plants varies depending on the location, operating capacity, population size, age of population, treatment methods, and discharge standards. In the calculation of indirect emissions from chemical consumption, the amount of cationic polyelectrolyte used annually in the plant and the cationic polyelectrolyte emission factor specified by 21 were taken into consideration. The amount of cationic polyelectrolyte used by 2019 is 53,000 kilograms and 48,000 kilograms. According to this data of emissions, amounts of the plant due to chemical consumption are calculated as 64 tons per cubic meter and 58 per 2019. Emissions from the combustion of biogas obtained from anaerobic digestion of primary sludge and biological sludge were calculated according to the table. The emissions from the biogas was 5,000 tons carbon equivalent. In 2018, there was produced 4,558 square meters of the biogas. Therefore, due to unreliable data in 2019, we have rated as 0. The emissions shows that 22 were combustion emissions from total emissions. In a small scale wastewater water treatment plant using membrane bioreactor technology, and emission from electricity consumption to greenhouse gas emission was 79% and 17%. Studies to date have shown that significant portion of a treatment plant can be met through biogas recovery processes. Reported that 2,900 kilowatts per day electricity can be generated from wastewater treatment plant with biogas conversion rate of 1,150 square meters for anaerobic digestion. In an advanced treatment plant in Turkey, it was determined that 30% of the total daily energy requirements of the plant had been met by combusting the methane in the system. Emissions from different units of the advanced biological wastewater treatment plant were analyzed and summarized. The total carbon footprint of the advanced biological wastewater treatment plant was estimated 10,490 and 54,000 tons carbon dioxide. The carbon footprint was reduced by generating electricity from biogas generated in 2018 in 60%. Due to the operational problems in 2019, the carbon footprint increased 5 times due to increase of greenhouse gas emission and the inability of provide energy recovery. In conclusion, the studies show that wastewater treatment plant process configuration and operation are very important in reducing carbon footprint. It is possible to reduce the carbon footprint through the sustainable plant design and optimization of operational parameters. In the study, the greenhouse gas causing processes of an advanced biological treatment plant and the carbon footprint of the plant were evaluated. Direct and indirect emissions are included in the carbon footprint assessment. As a result of the calculation of direct greenhouse gas emissions, it was determined that the process emitting the highest amount of greenhouse gases was an anaerobic stabilization plant, and the process emitting the least carbon greenhouse emissions was advanced. The study shows that have significant impact on the carbon footprint on this facility stated differently and operation facts. So thank you very much for listening me.